This is the University of Cincinnati Aerial Vehicles team presenting our flight readiness review. Our team members' names are listed below. Starting off with the system overview, we have Zalea, which is our hexacopter, powered by 4 6S 22 amp hour LiPo batteries. It is flown with payload and winds up to 18 knots average and 22 knot gusts. It's flown for a total time of 134 minutes during this competition cycle and has a weight with payload of 49 pounds. The ground vehicle has 2 wheels and a passive tail and weighs 3.1 pounds, both shown on the right. On the software side, we use Flymaster, a custom ground station software, to interface with ROS. This is also used with gazebo simulations, and the custom GUI on the right shows obstacles, boundaries, flight path, etc. We also have dedicated controllers for each of the software subcomponents, such as interrupt client, path planning, and obstacle avoidance. We plan to complete autonomous flight, obstacle avoidance, and the airdrop tasks. We will not be attempting the mapping or object detection, classification, localization tasks due to supply chain issues with our camera. Developmental testing. First, UAV specific tests. The UGV specific tests, each done separately. We then incorporate the AUVSI specific tasks, minus the camera ones, to the UAV, before leading into combined testing of UAV with UGV, leading up to a full mission demonstration. For software, we start with unit tests, then integrated software tests, then software in the loop with the gazebo simulations, which provides a realistic model and autopilot of the UAV or UGV. We then do hardware in the loop testing, followed by real flights. For hardware, you can see some of the tests we've done. The airdrop is shown on the left, which is done from a stairwell. The UGV driving is shown on the right, which was done in a parking lot. We also tested the release mechanism and FPV systems before integrating them onto Zalea. For autonomous flights, we completed 20 total for a time of 70 minutes, where 52% of that time was spent in autonomous mode. The tuning was done with Arducopter's AutoTune, which provides gains for the various controllers in Arducopter's firmware. We also applied a harmonic notch filter to deal with vibrations. For waypoint performance, we first did 12 scored simulations with 98 total waypoints, where 100% of those waypoints were hit, and an average miss error of 5.2 feet was returned. We then did 17 total real flights, 7 of which were graded through the interrupt, where we had 94% of waypoints hit and an average miss error of 5 feet. For obstacle avoidance, we again did 12 simulations with an average of 6 obstacles, where 97% of those were avoided. Before doing real flights, we increased the minimum distance around obstacles. We then did 9 real flights with an average of 5.5 obstacles, and 100% of which were avoided. For the airdrop, we completed 6 airdrops, where all 6 survived, 3 of which were scored, and the average distance to the target was 6.5 feet for those, and the average distance from drive to target was not measured. Testing. The video on the left shows the ground station launching and Zalea taking off, as well as the UGV. Waypoints and obstacles are shown, as well as the blue flight boundary, the red search area, the airdrop location on the left, the green waypoint, as well as the drive-to location at the blue waypoint. Altitude callouts are on the left, as well as battery voltage on the right, and throttle. The video on the right shows an airdrop of the UGV from 120 feet. The UGV would then land, we measure the distance from the target, and the UGV would continue its mission. Full mission testing covered autonomous flight, obstacle avoidance, and the airdrop. We did find flaws and loss of communications at the ground station. To address that, we changed to persistent systems radio, which has an increased range. We also had no drive-to location measurements due to poor ground marker accuracy. So we average more GPS points while picking the drive-to location. And again, we found that we intersected obstacles occasionally, so the minimum distance around obstacles for avoidance was increased. Here's the estimated scoring from our full mission tests. The average is shown. For autonomous flight, it's 97%, obstacle avoidance 100, airdrop accuracy was 50%, drive position, mapping, and ODLC all have nothing. The operational excellency was given a 75% by our advisors. The expected competition performance is slightly increased for most of those categories as we've been refining our process over the last few weeks. That is all. Thank you.